Our mass was 11.9 grams, our diameter was 40 centimeters, our radius was 20 centimeters, our height was 80 centimeters, and our temperature was 62.2 degrees Celsius.
So in order to find the volume of our hot air balloon, we needed two things: the diameter of the balloon and the height of the balloon. As you can see on the piece of paper, we found out that the diameter of the balloon was 40 centimeters and the height was 80 centimeters. The formula for volume is pi r squared times height. The radius, which is half of the diameter, is 20 centimeters. So the original equation, once we substitute all the numbers in, is 3.14 times 20 squared times 80. 20 squared equals 400, which brings us to the next step. And then you multiply 3.14 times 400 centimeters times 80 centimeters. This brings you to a total of 100,480 centimeters cubed. Centimeters cubed is equal to milliliters, so it's also 100,480 milliliters. Divide this by 1,000 to get liters, and you get 100.48 liters. Thank you.
In order to find moles, you have to do PV over RT, which means pressure times volume over R times temperature. And in this case, the pressure was 1 atm, the volume was 100.48 liters, R was 0.08206 liters times atm over moles times Kelvin, and the temperature was 62.2 degrees Celsius. So to convert that into Kelvin, you do 62.2 plus 273.15, and that equals 335.15 degrees Kelvin. So we did 1 atm times 100.48 liters over 0.08206 times 335.15 Kelvin, and we got 3.6536 moles.
To find the density of the hot air balloon to see if it will fly, we take the volume that we've calculated earlier and the moles that we calculated earlier, along with the mass of the hot air balloon itself, and we plug those into the density equation. After calculating the density using the equation, the density comes out to be 1.17 grams over liters, which rounded equals 1.2 grams over liters, overall allowing the balloon to fly.
The hot air balloon was able to rise because the density of the hot air balloon itself was less than the density of the air. Our density calculated to be 1.17, which is 0.03 less than the density of air, which is 1.2. Additionally, our balloon flew because as the hot air balloon was heated, the molecules inside the balloon sped up, causing the collisions inside to increase. Now, because there were more collisions on the inside of the balloon than on the outside of the balloon was pushed up until the collisions inside and outside became the same.